Hi folks, so the video today, what we're going to be going over is another video on profiles, but specifically these ones are a little bit more kind of real world based rather than just getting profiles. We're throwing a couple of little different scenarios at us as well. Okay, like I said in a previous video on profiles, these come up in the section C questions on the Leaving Cert paper in the applied graphics section on the area on road geometry, otherwise known as geologic geometry. So 3 questions on the page. We're going to start here with the top one, so I'll just flash into that one there now. So for question number 1, it says the map shows ground contours at 10 meter vertical intervals. Okay, so we can see here the distance between our contours, and we've actually got a vertical section profile here along the line AB, and the distance between our contours 80 to 70 to 60 is 10 meter gap between them. It says on the map draw a vertical section profile along the line AB. So we've done that in previous videos, so we'll speed up on that part. And then it says the valley contains a lake. Draw a line on the profile to indicate the surface of the water when the lake is 15 meters deep. Okay, so we'll get on to the second part of that in a minute. Now, first of all, as always, starting off with this question, we're given a scale. So 1 millimeter is to 1,000 millimeters. Okay, just put in mm there. Okay, so 1 millimeter on my sheet, OS, is to 1,000 millimeters in reality. Okay, now the distance between our contours is 80 to 70 is 10 meters. So we're trying to work up to 10,000 millimeters, because 10,000 millimeters is equal to 10 meters. Okay, in reality, that's what we're trying to work up to. So what did I multiply this by to make this, essentially? So I multiplied it by 10. And if I multiply this by 10, I also need to multiply this by 10. So 10 times 1 is 10 as well. Therefore, the kind of magic number that we're going to use for our profile is 10 millimeters, okay? Because 10 millimeters on our sheet is equal to 10,000 or 10 meters in reality, okay? And that's what we're going to use. So, first of all, identify on the the profile AB where the lowest mark is, and I'm just looking along here. So, not sure what that one is passing through. I'm going to assume, what, 60, sorry. So 60, I think the lowest is 40 and the highest is 80. So I'll come to the side here, and what I'm actually going to do is do a vertical line, and along that line then I'm going to start it at, just thinking I'll start here at 30, and then every 10 after that, so it'll be 40, 50, 60, 70, and finally 80. So each one after that then, I've got my 40, 50, 60, 70, and 80. Put in a little bit better there. So there's my 80. And what I'm going to do for each one of them, so putting in those profile lines, going horizontally across, so that's the 41 done. 50, 60, 70, finally the last one at 80. Okay, now what I'm going to do is where those contours are passing through that vertical section profile, I am going to project them up. So I'm just going to start with this one. I can see it's 70, so that one goes up to there. This one is up to the 80. Let's speed up the video now. Okay, there we have the vertical section profiles. That's the first part of the question done there. On the map, draw the vertical section profile along the line AB, which we have done. And it also says then, and this is kind of bringing more of a real world scenario into it, it says the valley contains, you can see here we've obviously got a valley, okay, we're high part of the mountain here, high part of the mountain, okay. The valley contains a lake, okay. Draw a line on the profile to indicate the surface of the water when the lake is 15 meters deep. Okay, so it's just using a little bit of common sense here, but essentially what they're asking us to do is draw a line across, okay, in the valley when the lake is 15 meters deep. Now just down here where I had a 40 and a 40 contour, okay, it didn't make sense to just go straight across because the direction of the land was going in a downward profile and it was going downward here. So what you do is you usually dip it down. Now there is some debate on how far you should dip. I always, depended on how far the contours are apart, okay, and the points, I kind of go anywhere from about 1 to 2 mil apart, okay. If the contours were really far apart, I might go maybe 1, maybe 2, and then likewise up here you can see it was a lot closer and it was going upwards, okay. So I kind of go down about 2 millimeters. So what I'm going to do is, where the valley is, I know that 1 millimeter on my sheet is equal to 1 meter in reality. So where the valley is, I'm just going to pick the lowest point, which is right there. I'm going to measure up 15 millimeters. From the 50, I'm just starting on the 50. And I'm going to measure up 15 millimeters. So there's 10. 15 will be right there. So where the 15 is, I'm going to draw a line straight across, and there we have a 15 meter deep little lake of water, okay, and that's kind of showing how high it would come up then on the left hand side of the valley and the right hand side. Okay, so just a bit more of a real world scenario there, guys. Now what we're going to do is move on to question 2, which is in the middle of the page. Okay, so for question 2, it says the map shows ground contours at 5 meter intervals. So we can see here 50 to 55, the distance between them is 5. On the map, draw the vertical section, okay, along the line AB, so the profile. And then it says the next part, an observation tower will be placed at X. Okay, so we have X here. What is the minimum height of this tower if it must be seen from B? Okay, and then our scale is 1 to 1000. So like the last question, we'll focus on the profile first and then we'll do the second part, okay? So our scale is 1 to 1000. So I'm just going to come over here now, and 1 millimeter on my sheet, so OS there, is equal to 1000 millimeters in reality, IR. And the distance between our profiles is 5, okay, so there we're trying to work up to 5000 millimeters. So what did I multiply this by? I multiplied it by 5 to get 5000, so I also have to multiply what's on my sheet. Therefore our magic number is 5 in this case, okay. So looking at the profile, I'm going to go along here and see what the highest is. So 35 seems to be my lowest, okay, and then goes 40, and my highest is 75. So 35 is the lowest and the highest is 75. So a good one to start on maybe is 30 here, okay. I'm going to do vertical line up, and I'm going to measure distances of 5 millimeters. So that will be 35, 40, 45, 50, 55, 60, 65, 70, 75. Okay, so with each of these, I'm going to send a line across. Obviously you'll be using pencil, just for the purpose of the video. I'm doing it in pen, it stands out better. Okay, so putting in these, so I'll go up to, I'll write them up in tens actually, 50, 60, 70, and then obviously 75 is at the top. Okay, so I'm going to speed up the video there while I plot the profile. We've done this enough times now. Okay, there you can see we have done the vertical section profile along the line AB, and it was just saying, sorry, I've done the vertical section profile along the line AB, and what we have to do now is we have to do the part B of the question. So it says, an observation tower will be placed at X. Okay, so we've got an observation tower is going to be placed at X, so I've marked X already, and it seems to be right on the 60 contour height. Okay, and it says, what is the minimum height of this tower if it must be seen from B? Okay, so what I'm going to do is just going to draw in a line up there like that. Okay, and essentially that line there going from X is going to be our tower. We don't know what height it is, but if you imagine a person was here at B, what it's saying is, what is the minimum height of this tower if it's to be seen from B? Therefore, essentially the person at B can only see above the top of the mountain here. So we can see the top of the mountain there. So what I'm going to do is actually put this in green. I'm going with pen first actually. So if I just draw a line just to go over the top of the mountain there, you can see it there, let's put it in green, that will actually show us how high the tower has to be when we would finally just see it there. So that green line there would technically be my line of sight. That's my line of sight right there. Okay, and what's more important to us though is our tower height. And there is the height of our tower, there to there, and as it says, what is the minimum height? So there's the tower height, and if I was actually to measure that now, so just measuring that from here, so it's 10, 20, it seems to be about 27, so 20, 25, 26, 27 meters, so our tower will be 27 meters high. Okay, so 27 meters, okay, from where X is for it to be seen from B. Okay, so once again, just a little bit of reading of the question and trying to understand it. Okay, as always, the profile is the main part of it, but then obviously just using our little bit of common sense there to work out the second part. So what we're going to do now, guys, is move on to the third question at the bottom of the page. So the last question on this page, guys, it says the map shows ground contours at 10 meter intervals. We can see the distance between our contours is 10 meters. It says on the map draw a vertical section profile along the line AB, and then it's asking us a 50 meter high wind turbine is placed on the profile at point Z, so we can see Z here, and can this be seen from X? Okay, so and then a second turbine. Alright, so we'll actually have to draw the profile first, okay, which is this first part, before we get on to the little bits of kind of real world scenarios before for doing that. Okay, so as always, using our scale is 1 is to 1000, so 1 millimeter on my sheet is 1000 millimeters in reality, so OS and then IR. Okay, and what we're trying to work up to is a distance of 10 meters, which is otherwise 10,000. So therefore, what did I multiply this by to make 10,000? So 1000 multiplied by 10 gives me 10,000. Therefore, I have to multiply 10 also by 1 millimeter. So that's also 10. So 10 times 1, that's kind of our magic number. So the distance we're going to be traveling up for our profile is 10 millimeters. Okay, so starting with our lowest, I can see just looking along the line there in the numbers, our lowest is 30 and our highest is 80. So I'll come here, put in a vertical line. So if our lowest is 30, 40, 50, 60, and 80. Right. So what I've done is, where those little marks are, you can see them there. Okay, I've measured up a distance of 10 millimeters for each one. Okay, and now what I'm going to do is draw in my contour heights. Okay, so that one there is marking 20, 30, 40, 50, 60, 70 and 80. Right, so what I'm actually going to do now is where the line AB, the vertical profile, is passing through the contours, I'm going to project them up to find my profile up here. So I'll speed up the video for that. We've done that numerous times. Okay folks, so there we have it. That is the vertical section profile along the line AB. So what I'm actually going to do now is I'm just going to mark my points here. So there's X, Y is here, and then we have Z here. Okay, so the question is, a 50 meter high wind turbine is placed on the profile at point Z. Okay, can this be seen from X? Okay, so what we're going to do is we're going to put in the 50 meter high profile, okay, at Z. So from Z, we've got a wind turbine. I'm going to project up a line there, and on that line I'm going to mark a distance of 50 meters. So from Z, I'm at 5, 50 will be there. So 5 up to 10. So there's a little wind turbine. I'll actually put it in heavy now while I have it. Okay. And if you imagine, okay, might have something like that there. Okay, there's a little wind turbine. And what they're saying is, can this be seen from X? So going to the top of it, which will be right here at the 50 meter height. If I was to put in my line of sight there, and once again I'll use a green. Can this be seen from X? We can see obviously it's going through the mountain, so clearly it cannot be seen. So what I'm going to write on that is no. Okay, and what we have to do now is it's saying a second turbine, also 50 millimeters or 50 meters in height, is placed at Y. So different position here. So we can see it's a bit higher in the mountain, so I'm hoping that this one should be able to be seen. So once again, drawing a vertical line, and from Y going to measure up a distance of 50. So 5 up to 10 once again, right there, and once again I'm actually heavy in that, and mark it right there, maybe something like that. Okay, so there's our little turbine, and what they're asking is this time, can this be seen from X? So if I go to the top of it, I'll line it up with X, and we can actually see in this one the mountain is not kind of obscuring it, okay, or getting in the way of it. So therefore for the second one, the turbine in position Y, that in green for my line of sight once again, for the second one, yes, we can see it. So yes, we can see that one. Okay, we couldn't see the first one because it was a bit lower on the mountain and a bit further behind us. Therefore, we actually would have to cut away the mountain to be able to see it. Whereas in the other one, our line of sight isn't actually obstructed by anything. So yes, we can see that one. Okay. Once again, guys, that's a little bit of kind of a real world examples brought into it, using the profiles then to help us as well. Okay. So you can see here we have to use the profiles to be able to determine the answer for the second part of this question. Okay, that's the second videos there on profiles, guys. Hope you found that helpful.